You know, drying. It's something we see every day, right? So simple we barely even think about it. But what if I told you that in the world of medicine, that simple act is actually a high-stakes, multi-million-dollar science? Let's peel back the layers on one of manufacturing's best-kept secrets. So when you think about how medicine is made, what comes to mind? Probably gleaming labs, complex machinery, right? But the most critical step, the one where an entire batch of life-saving medicine can be totally ruined, is probably not what you're thinking of.
Yep, that's right. Drying. In an industry where precision is literally everything, the simple act of removing water is where the real magic and, the real risk actually lies. To really get why, we've got to dive into the physics of what I like to call a water molecule's great escape.
At its heart, drying is a battle. Seriously, it's this constant tug-of-war between two really powerful forces. And the whole goal is to convince water molecules to just pack their bags and leave the solid material they're clinging to.
This slide really breaks down that battle perfectly. On one side of the rope, you've got heat transfer. You can think of this as the push. It's the energy that zaps the water molecules and tells them, hey, it's time to go. And on the other side, you have mass transfer. That's the pull. This is the process that actually carries those molecules away. You need a perfect balance of push and pull, otherwise it just doesn't work.
So how do engineers rig this tug-of-war in their favor? Well, they've got a few tricks up their sleeve. They can crank up the heat, create a stronger breeze with more airflow, or even make the air itself thirstier by lowering the humidity. Each little tweak gives those fleeing water molecules a much better shot at making their escape. To really get this, we need to zoom way in. I mean, let's follow a single water droplet on its dangerous journey out of a wet granule. And trust me, this isn't just simple evaporation. It's a dramatic, multi-stage escape mission. This quote just nails the central challenge. The escape is super easy at first, when the droplet is just hanging out on the surface. But as the material starts to dry out, that journey becomes this desperate struggle from the very core of the solid. The real problem, the real bottleneck, isn't at the surface, it's deep inside.
Okay, so here's how that escape plays out. First, you've got a little warm-up period. Then comes the constant rate. This is the easy part, the free run. The surface is soaked and water is evaporating like crazy. But then, things get tough. Dry patches start to show up and the first falling rate begins. And finally, you hit the second falling rate. The surface is completely dry now. Any water that's left is trapped deep inside, and its escape is a long, slow crawl.
And that exact moment, that instant where the escape goes from a full-on sprint to a painful crawl, it has a name. It's called the critical moisture content. It's the tipping point. From this moment on, getting every last drop of water out is a hard-won victory. So when is the journey finally over? You might think it's when the material is bone dry. But nope, it's when it reaches a perfect balance with the air around it. This state is called equilibrium moisture content. At this point, the tug-of-war is basically a draw. Trying to dry it any further is just a total waste of energy. Okay, so we get the struggle of that one little water droplet. Now, let's check out the incredible machines that engineers have designed to control every single step of that escape, from the simple workhorses to the really high-tech innovators.
First up, we've got the classic, the tray dryer. Just think of it as a big, really, really precise oven. It's super reliable, but boy is it slow. And it requires a lot of hands-on work. Now, this is where things get really clever. A fluidized bed dryer doesn't just let the granules sit there, no way. Instead, it blasts hot air up from the bottom, which causes all the little particles to float and tumble around like a boiling liquid. It's amazing to watch. Every single granule is surrounded by drawing air, which makes the whole process incredibly fast and super efficient. And this is the real game changer. What if your starting material isn't a solid, but a liquid? A spray dryer takes that liquid, atomizes it into a superfine mist inside a whirlwind of hot air. The droplets dry so fast, they literally turn from liquid into a perfect powder before they can even hit the bottom. It's wild.
So let's just recap. You've got the slow and steady tray dryer, which takes hours. Then you have the fluidized bed, which gets the job done in minutes. And finally, the spray dryer, which is pretty much instantaneous. Choosing the right tool for the job all depends on what you're drying and, of course, how fast you need it done.
So we've seen the physics, we've seen the incredible technology, but you might be wondering, why all this effort?
Why does chasing down every single last stubborn water molecule matter so much?
Well, it matters because the payoff for all this precision is absolutely huge. Proper drying keeps the medicine stable, which stops it from degrading. It stops nasty mold and bacteria right in their tracks. It makes sure every single pill has the exact right dose. And on a practical level, it makes products lighter and way easier to ship around the world. In short, it's what makes modern medicine even possible.
And when we talk about precision, it's just astounding. Just to find that perfect finish line, that equilibrium moisture content we talked about, can take over a month of meticulous testing for just a single new drug.
Okay, so here's the core science behind it. Water isn't just wet. It's actually a catalyst for all kinds of unwanted chemical reactions. So by removing it, you lower what scientists call its water activity, which is basically its power to cause trouble. The drier the product, the safer and more stable it is. Simple as that.
So the next time you take a pill, just take a second to remember the incredible journey its ingredients went on. The science of drying is such a powerful reminder that some of the most amazing complexity is often hidden in plain sight. It really makes you wonder, what other everyday miracles are we taking for granted?